Good morning students. Today we are going to see Unit 5 Acoustics, Learning Objectives, Conditions for no Doppler effect, Applications of Doppler effect. Now let us revise previous class portion. Longitudinal wave. What is called longitudinal wave? A longitudinal wave is a wave in which the particles of the medium vibrate along the direction of propagation of the wave. The particles of the medium vibrate along the direction of propagation of the wave. See this diagram. It is a sound propagates as a longitudinal wave. In this we have compression and rarefaction. Now what is compression and rarefaction? The series of high pressure region is called as compression, and then the series of low pressure region is called as rarefaction. Categories of sound waves based on their frequencies. Audible wave. What is called audible wave? These are sound waves with a frequency ranging between 20 Hz to 20,000 Hz. These are generated by vibrating bodies such as vocal cords, stretched strings, etc. Infrasonic waves. What is called infrasonic waves? These are sound waves with a frequency below 20 Hz. Frequency below 20 Hz. Example, waves produced during earthquake, ocean waves, sound produced by whales, etc. Ultrasonic waves. What is called ultrasonic waves? These are sound waves with a frequency greater than 20 kHz. Frequency greater than 20 kHz. Human ear cannot detect these waves, but certain creatures like mosquito, dogs, bats, dolphins can detect these waves. Example, waves produced by bats. Audible waves ranging between 20 Hz to 20,000 Hz. Infrasonic waves range below 20 Hz. Ultrasonic waves ranging greater than 20 kHz. Particle velocity. What is called particle velocity? The velocity with which the particles of the medium vibrate in order to transfer the energy in the form of a wave is called particle velocity. The particles alone vibrate in a wave is called particle velocity. Important 2 more question. What is called wave velocity? The velocity with which the wave travels through the medium is called wave velocity. The wave itself travels in a medium, then we have to say it is called as wave velocity. Factors affecting velocity of sound. In case of solid, the elastic properties and the density of the solids affect the velocity of sound waves. That is, the speed of sound is directly proportional to the square root of the elastic modulus and inversely proportional to the square root of the density. But in case of gases, the velocity of sound waves affect the effect of density, effect of temperature and effect of relative humidity. Reflection of sound. What is called reflection? When sound waves travel in a given medium and strike the surface of another medium, they can be bounced back into the first medium. This phenomenon is known as reflection. What are the laws of reflection? State the 2 laws of reflection. Important question. State the 2 laws of reflection. The incident wave, the normal to the reflecting surface, and the reflected wave at the point of incidence lie in the same plane. The angle of incidence and then the angle of reflection both are equal. The incident wave, the normal to the reflecting surface, and the reflected wave at the point of incidence all lie in the same plane. The angle of incidence is equal to angle of reflection. In this diagram, the sound wave that travels towards the reflecting surface is called incident wave. The sound wave bouncing back from the reflecting surface are called reflected wave. A perpendicular line drawn at the point of incidence is called normal. The angle between the reflected wave makes with the normal is called angle of reflection. reflection at the boundary of a denser medium. See this diagram. A compression traveling in air from left to right reaches a rigid wall. The compression exerts a force F on the rigid wall. In turn, the wall exerts an equal and opposite reaction, that is R is equal to minus F. This results in a compression near the rigid wall. Thus, a compression traveling towards the rigid wall is reflected back as compression. So, that is the direction of compression is reversed in this diagram. And the next topic, reflection at the boundary of a rarer medium. How the reflection takes place in a rarer medium. A wave traveling in a solid medium striking on the interface between the solid and the air. The compression exerts a force F on the surface of the rarer medium. As a rarer medium has smaller resistance for any deformation, the surface of separation is pushed backwards. As the particles of the rarer medium are free to move, a rarefaction is produced at the interface. Thus, a compression is reflected as a rarefaction and a rarefaction travels from right to left. Now, let us see what is called denser medium and what is called rarer medium. Very important question. What is meant by rarer medium and denser medium? The medium in which the velocity of sound increases compared to other medium is called as rarer medium. The medium in which the velocity of sound decreases compared to other medium is called denser medium. Reflection of sound in plane and curved surfaces. When sound waves are reflected from a plane surface, the reflected waves travel in a direction according to the law of reflection. Here the intensity of the reflected wave is neither decreased nor increased. In a plane surface, the intensity does not change. Now what happens to the curved surface? In the curved surface, the sound waves are reflected from the curved surface. The intensity of the reflected wave changed. In curved surface, the intensity of the wave changed, whereas in plane surface the intensity of the wave does not change, whereas in curved surface the intensity of the wave changed. Echo. What is called echo? An echo is the sound reproduced due to the reflection of the original sound from the various rigid sources such as walls, ceiling, surfaces of mountains, etc. Next one, conditions necessary for hearing echo. What are the conditions necessary for hearing echo? There are two conditions necessary for hearing echo. What are they? First one, the minimum time gap between the original sound and an echo must be 0.1 second. Second one, the minimum distance required to hear an echo is 17.2 meter. These are the two conditions. Minimum time gap 0.1 second, minimum distance 17.2 meter. Applications of echo. What are the applications of echo? Echo is used for the animals to communicate with each other over long distances, and then echo is used in a medicinal field, and this echo is used to determine the velocity of sound waves in any medium. Applications for reflection of sound. What are the applications for reflection of sound? Soundboard. It is used in soundboard. How it is used in soundboard? These are basically curved surfaces, that is, it is a concave surface which are used in auditorium and halls to improve the quality of sound. This board is placed such that the speaker is at the focus of the concave surface. The sound of the speaker is reflected towards the audience, thus improving the quality of sound heard by the audience. Ear trumpet. Ear trumpet is a hearing aid which is useful by people who have difficulty in hearing. Megaphone. It is a horn-shaped device used to address a small gathering of people. Doppler effect. Very important question and also important concept in this lesson. What is called Doppler effect? Whenever there is a relative motion between a source and a listener, if there is a relative motion between a source and a listener, the frequency of sound heard by the listener is different from the original frequency of sound emitted by the source. The frequency changes to the listener. Then we have to get the Doppler effect. If there is a relative motion between a source and a listener, the frequency changes, so the Doppler effect will produce. So what is called Doppler effect? Whenever there is a relative motion between a source and a listener, the frequency of the sound heard by the listener is different. Frequency of the sound heard by the listener is different. That is the sound having high pitch and low pitch, if there is a relative motion between source and a listener. From the original frequency of the sound emitted by the source, that sound is different when we compare with the original sound of the source. So it is known as Doppler effect. Now expressions for apparent frequency due to Doppler effect. Very important expression in this lesson. Expressions for apparent frequency due to Doppler effect. What is apparent frequency? The apparent frequency is the frequency of the sound as heard by the listener. The frequency of the sound heard by the listener is called apparent frequency. Okay, very important expression in this lesson. See this diagram, source and listener. Here the source and listener both are moving towards each other. So when both the source and listener are moving towards each other, then what is the expression? The expression is n dash is equal to V plus VL by V minus Vs into n. When both source and listener are moving towards each other, the expression is n dash is equal to V plus VL by V minus Vs into n. What is n dash? Apparent frequency. What is n? Original frequency. And then VL, velocity of the listener, Vs, velocity of the source. Now this is the source and listener are moving towards each other. See this expression, n dash is equal to V minus VL by V plus Vs into n. This expression is for both the source and listener are moving away from each other. Source and listener moving away from each other. So in this expression, n dash is equal to V minus VL by V plus Vs into n. That is, both the source and listener are changing its direction. When both of them are changing its direction, we have to change the sign in the first equation. Instead of plus, we have to write minus Vl. Instead of minus Vs, we have to write plus Vs. When we remember these two expressions very clearly, it is easy for you to study the remaining 6 expressions given in your book. So when both are moving towards each other, the expression is n dash is equal to V plus VL by V minus Vs into n. When both are moving away from each other, then the expression is n dash is equal to V minus VL by V plus Vs into n. Now conditions for no Doppler effect. What are the conditions for no Doppler effect? When source and listener both are at rest. Source and listener both are at rest. When both of them are at rest, there is no change in the frequency of the sound. So there is no Doppler effect. Second one, when source and listener move in such a way that distance between them remains constant. Source also moving and listener also moving, but there is no change in the distance. When both of them move, if there is a 10 centimeter, means the 10 centimeter distance remain same as they move in a path. So when source and listener are moving as a same distance, that they maintain the distance as a constant. Both of them are moving in such a way that the distance between them remains constant. If there is a 10 centimeter, after 1 hour also it is a 10 centimeter. After 3 hours also it is a 10 centimeter. So there is no any Doppler effect. When both of them are at rest, there is no Doppler effect. When both of them are moving in such a way that the distance remains constant. Next one, when source and listener are moving in mutually perpendicular direction. See this diagram. Source and listener, both of them are moving in perpendicular direction. When source is moving in this direction and then listener is moving in this direction. So both are perpendicular to each other. When both of them are perpendicular to each other, there is no Doppler effect. Next condition, if the source is situated at the center of the circle along which the listener is moving. See this diagram. Here the source is situated at the center, and then here the listener is moving. So here there is no Doppler effect. Why there is no Doppler effect? Here the frequency of the source is 800 Hertz. The same frequency only heard by the listener, that is observer. So there is no Doppler effect. You already know that if there is a frequency change, then only the Doppler effect will take place. But here there is no any frequency change. When there is no any frequency change, if the source is situated at the center of the circle which the listener is moving. So if the source is situated at the center of the circle along which the listener is moving, there is no Doppler effect. There is no any frequency change. So there is no Doppler effect. So what are the conditions for no Doppler effect? The first one is when source and listener both are at rest. Source and listener are stationary. There is no Doppler effect. When source and listener move in such a way that distance between them remains constant. Distance between the source and listener are same when they are moving, while they are in a movement. So there is no Doppler effect. When source and listener are moving in mutually perpendicular direction, both of them are moving in perpendicular direction, there is no Doppler effect. And last condition, if the source is situated at the center of the circle along which the listener is moving, there is no Doppler effect. These are the conditions for no Doppler effect. Next topic, applications of Doppler effect. Mention the applications of Doppler effect. To measure the speed of an automobile. How it is used to measure the speed of an automobile? An electromagnetic wave is emitted by a source attached to a police car. In a police car, they are having a electromagnetic wave. It is attached in a police car. Now the wave is reflected by a moving vehicle which acts as a moving source. This wave also reflected by a moving vehicle. So there is a shift in the frequency of the reflected wave. If there is a change in the frequency of a reflected wave, from the frequency change, the speed of the car can be determined. So it is used to measure the speed of an automobile. So an electromagnetic wave is emitted by a source attached to a police car. The wave is reflected by a moving vehicle which acts as a moving source. There is a shift in the frequency of the reflected wave. From the frequency shift, the speed of the car can be determined. This helps to track the overspeeding vehicles. Tracking a satellite. How it is used in a tracking a satellite. The frequency of radio waves emitted by a satellite decreases as the satellite passes away from the earth. When the satellite moves away from the earth, what happens to the frequency of the satellite? It will decrease. So by measuring the change in the frequency of the radio waves, the location of the satellite is studied. By changing the frequency of the wave, we have to find out the location of the satellite. When the frequency decreases, we have to find out the difference between the frequency, high frequency and low frequency. By finding the difference between high and low frequency, we have to find out the location of the satellite. So this tracking a satellite is used in the application of Doppler effect. Radar, radio detection and ranging. In radar, radio waves are sent and the reflected waves are detected by the receiver of the radar station. See here, it is a reflected wave. This reflected wave are detected by the radar station. From the frequency change, the speed and location of the aeroplanes and aircrafts are tracked. By finding the frequency change, the speed and location of the aeroplane can be found out. So in radar, they send the radio waves and the reflected waves are detected by the receiver of the radio station. They have to find out the reflected wave by using the receiver present in the radar station. By finding the frequency change, they have to find out the speed and location of the aeroplanes and aircrafts. Sonar, sound navigation and ranging. In sonar, by measuring the change in the frequency between the sent signal and received signal, the speed of marine animals and submarines can be determined. Very important application of Doppler effect. Sonar, in sonar, by measuring the frequency change between the sent signal and received signal. See this diagram, this is the sent signal and this one is a received signal. By finding the changes in the sent signal and received signal, they have to find out the marine animals and submarines can be determined. So this is the uses of sonar. So in sonar, by measuring the change in the frequency between the sent signal and received signal, the speed of marine animals and submarines can be determined. So mention the applications of Doppler effect. Very important question. Where the Doppler effect are used to measure the speed of an automobile, tracking a satellite, in radar and sonar. Thank you, students.